Hey, W5HR. Well, it's been what, 3 to 4 days maybe since I did the last video. Well, I decided I better tackle this AVC circuit, this limit control before I put this thing back in the transmitter. Plus, that tubular cap down there, that 0.1 to ground I put on the input of that choke just to keep any noise. Because I don't know if I told you, when you build power supplies and you're doing like choke input and you're not going to put a, electrolytic cap on the, you're not going to put one on the input side, but you're going to have it on the output, right? Sort of like an L network. It's like LC going to ground. Well, this is not like a pi network choke where it's a capacitor input filter. I've done a choke input. However, I have a 0.1 mic, a non-polarized cap. And it's just a 0.1. All it does is it keeps noise from coming back into the diodes that I have here, the big diodes that are rectifying the output of the transformer. Because what will happen is if you put a scope on the input, the actual choke itself, it'll create some ringing, and you'll be surprised what you can see on the input if you don't put like a 0.1 down the ground, as long as it's not a polarized cap. Of course, 0.1s usually are not polarized, it's a 0.1 mic. But if you say you could probably put a 10 mic on this, but it would have to be non-polarized. If it's a polarized cap, it's going to want to act like a capacitor input filter, and then the voltage is going to increase, your output voltage on the supply is going to increase dramatically. So I found this place, I ordered a lot of 16 of them. A guy had a big box of them. Still new old stock, so I ordered their new ones. This one is an old one. It was never used, but I can tell the stuff kind of inside. It's one of the old paper types, and I'd rather have a one that's more sealed, like in complete plastic, new old stock that was never used. That would be better. But what I've done is on this circuit is, like I said, I've decided that I'm going to go ahead and tackle the AVC now. So what I've got here, what I've actually got built right now, I've already updated this schematic. I don't know if you can see this or not. I should probably put some better light on it. But right now, I've got a 470K with a 1 mic going down the ground. And what I had to do was, this other supply I've got is 0 to 30 volts. It probably would have been enough, but I wasn't sure. And it looks like it may have been possibly just on the short side of it. So this is a 0 to 200 volt switching supply. I just got it. Found it on Amazon. They normally sell for like $159. They're like 160 bucks. I found one on there it was not a used one. It's brand new in the box. The box is over here behind me. I've got all the cables and the manuals. I'm going to hook it up to my laptop here. I need to get this computer set up out here again, because I can control this supply from the computer, which would make it's easier to punch in numbers on the keyboard to set the voltages and stuff than it is twisting these knobs and navigating on that display on the supply itself. They make a 300 volt, a 400 volt, a 600 volt, and an 800 volt, even 1,000 volts. This one all the way up to the 800 volt is a 1 amp switching supply, and the 1,000 volt is a half an amp supply. The 800 volt supply is like 600 bucks. So I thought what I eventually need is, this 200 volt was low enough. It was cheap enough that I could go ahead and afford to buy it now. And that way I get a chance to test this brand out, see if it's any good. Who knows? This thing could crap out after some use. You don't know. But this way I get a chance to test it, because if it holds up, then I'll eventually buy the bigger one, because I want some high voltage supplies here on the bench. I don't care if they're switching supplies. I just need the high voltage. Otherwise, I have to build my own high voltage supply setup here for testing stuff. If I want to breadboard a tube circuit and design and build something else, I don't have any supplies to start with to power it up to try it out. So I need bench supplies. But if I get, say, like the 800 volt supply, I'm going to need one or two smaller ones for like control grid and screen biasing and other biasing. So if I'm going to power out everything up, I'm going to need probably more than one supply, right? unless I use dropping resistors on everything, and that's not the way to go. So I want a bunch of supplies that I can set up here on my bench. I still need to set up my workshop here, this bench and everything. I'm still, look at the mess. So when I get this thing back in the shack after I try it out, I'm going to go ahead and clean this up over here a little bit more so I can bring that 810 modulator rack out here. So what I've done is I'm trying to find out exactly what control voltage I need, because I realize I'm going to need a fixed supply on this all the time to limit this thing, because what's going to happen is, remember I told you, let's go ahead and run this thing up now. Watch what happens. Let's peak it up again. Probably close enough. Well, that's no, I can go. But see now when I turn the input signal up higher, see what it does? Look. Whoa. And that's only like 30 millivolts. If I put 2 volts peak to peak into this thing, because a D104 will do like 4 volts peak to peak if you get up into it, but you know, 2 volts peak to peak, what do you think that's going to do? That's only like 30 millivolts. So watch what I do. I'm going to start, I'm starting at 1 volt on this. Now watch what I do. I'm turning the voltage up 1 volt at a time. Look at what it's doing. Look at that. Look at that. See what it does? And I'm at what, 31 volts? And it said this tube somewhere around 10 millivolts. Somewhere with around minus 10 volts into the control grid of this 6SK7 tube. Between it says minus 10 is where it starts to have the AVC action, to about minus 30. Well, because I have this thing triode connected, it's behaving just slightly different. Well, here's the thing though, too. No, I kind of take that back, because it's going through a 470K resistor. What's the voltage on this side? I should probably look at that right now. Where's my, I should have hooked up my voltmeter here before I started, I guess. I forgot I should probably look at this on the voltmeter. So, what is the actual voltage on the pin? Let me see here. I'm trying to get on here. Can you see the voltmeter? Let me go here. Let's see. So I'm getting almost 31 volts on the pin. Okay, with 31, okay, it's not much. It's because it's such a high resistance, it's such a high impedance input, it's just not that 470K, it's not really hurting anything. It's not really going to load it down much. Even a 1 meg wouldn't be that bad. So see, that's actually going to work, I think. Now, one of my other ham friends that's been watching my videos that I email once in a while, I got 2 or 3 guys I email from time to time, because I run things by them and they give me some advice every now and then if they see something I might have missed. And a lot of times they get it right, and a lot of times it's not going to matter. I just leave things the way they are. In this case, I think this is one of those cases, because he was telling me, and I read it. What I've been doing is let me turn this input down just for now. I don't want to leave it that high. I want to let this thing cool off while I'm talking. As a matter of fact, let me turn this thing back down to like, there. I just want to back this thing back down. There, it's good enough for now. So, but I had read, what I've been doing is I've been using AI, and I ask it questions, and I was asking it, because when I was going through some searching on some other questions, it told me that the AVC action of the 6SK7 would be degraded when it's triode connected like this. It said it would be just degraded enough to affect it a little, and it looks like it is, just barely maybe. Although you saw where I had that 30 volts, but see, this tube is supposed to, the muse of this tube is supposed to be, this tube should be almost in cutoff at minus 30 volts, and it's not doing it the way I have it set up here. It's going to take a little more. So what I have to see next is I have to check to see if I have enough output voltage swing coming off the diodes inside this 6SR7. So that's what I'm going to look at next. If not, this won't work, and I'd be better off putting a 6J5 in there instead. But anyway, I need to play around. I need to look at the voltage here, but right now I need to set this thing to 2 volts peak to peak in and see what voltage it takes to get this thing to stop doing that. Well, it's not going to matter anyway. What my plan on this thing is that I'm just trying to get the, because the D104 is a lot hotter, but at minimum voice tones, it'll be like around 10 millivolts, or so. So it's good. It needs to amplify. So 10 millivolts on low tones, that would be right. But see, that's with the audio gain all the way up. And when I talk louder, it actually, it's going to come up. So I just need to play around. I need to try to figure out exactly how much voltage I think I need coming out of this audio generator into this thing to try to simulate the D104 so I don't square the thing off at max levels. Because with 2 volts in, I guess what I could do is I could turn it up as high as it would go until the output, it doesn't go any higher and it doesn't change it, and then set it for that maybe. See what voltage it takes at the input to this 470K resistor to start, to get it to where it's not doing what I don't want it to do. So I need to play around with this a little bit and try to figure that out. Hopefully I'm making some sense. I'm kind of all over the place here because I got this power supply in a little while ago, and I downloaded the software. I need to put it on the laptop and try and play around with it, see if I can do that. But right now I can use it like this just to figure this out, I think. And that way I'll know how much voltage I need coming out of that diode, after it gets, after the 1/2 of the cycles clipped off from the diode. And then what I'm doing is that if it works, if I got enough voltage, this is what they were doing with that old circuit in that old 1947 RCA ham tips. And so I went ahead and I put similar value resistors, but it's basically the same circuit. So if I've got enough voltage, I can do this and I can make this pot. This may need to be a tiny pot. If I need a high voltage to get it depends on what I'm getting off these diodes. And see what I've done? I've just temporarily simulated. What I'm going to do is I'm going to take one of these symbols and copy it. Then I'm going to redo it, and I'm going to just take off the other, the suppressor grid and the screen grid to move the cathode up higher so I can draw the 2 diode symbols and add the 2 diode pins here so I can actually eliminate, I can change out this symbol here that I've got on this drawing to the one that looks like this. It'll just be a 6RS7. It'll be like the dual diode symbols, what it'll be. It'll have the dual diode in there. So it won't have the diode symbol, it'll just have the little lines. It'll have the pins that I can connect to on the drawing here for those diodes. And it's pin 4 and 5 is what I see. What I did, I labeled the diode 6SR72 and I put on here pin 4 and 5. I don't know if this is going to work. Like I said, if I get enough voltage out of that diode after I figure out what it needs to be, then I'm going to go ahead and modify this circuit to this and see if that works. And if it does, at least I'll have the AC, AVC, and the limiting working like I want it to. Now, I won't put the feedback. I'm probably not going to add the feedback now unless I absolutely have to. I could always come back and do that at a later date. So let me play around with this thing and figure out where I need the... and it's wiggling around a little bit because I have this long jumper. The power supply is on the control grid of that tube, so it's making it noisy is what it's doing. When I don't have these long wires and stuff on it, when it's done, that'll be gone. So let's see here. Let's run this thing. Let's run this thing up. You know what? Let's put it back. I think when I did it this way and had the knob up full blast, I think that was 100 millivolts peak to peak in, if I remember. Let's see now. Let me increase the voltage on this, and let's see where I need to be to get there's 29, 31 volts. Wow. See, I may not be able to get it. Wow. There's 60 volts into the grid. Oh my God. Yeah, see, that wouldn't be bad. See, if I could get it to where it never get any worse than that. Yeah, see, I'm dropping it way down. It's probably never going to get, that's 20 volts in right there. I don't think I'm going to be able to get it any more AVC than that now, because it's just being overdriven. But see, that's only like I need to see if that's 100 millivolts again. If it is, this thing's going to be overdriven. And you know what? If that's the case, I may have to change this, the biasing, because I've set these resistors for like minimum input signal here for maximum output with the least amount of input I could put in here. And now when I turn it up, it's actually, I may have to adjust these resistors to actually, mainly this one and this one. I may have to adjust these to get it so it doesn't do that with higher current drive and, you know, when it's trying to put more current in there, everything. So that may be, I may have to tweak these. I just realized that may be, but I need to see where that is. Is that 100 millivolts or is it more? If it was if that was 1 volt, I wouldn't care. But you can see what I'm doing here. I'm actually getting this thing. I mean, this thing is like, it's coming to life. I mean, the AVC is fully functional on this. I mean, I just think I have way too much gain. And I think, you know what I'm thinking? And what I told my other ham buddy is that I will go by what they said it would work triode connected like this. And what I'm thinking is I would just about bet you money when the guy, I need to go back and read, I need to figure out who the ham was again that wrote this article. But I have a hunch, if it would have been me and I was building this thing, I was trying to figure out a design back in the late 1940s like this, the first thing I would have done, there would have been no reason for me at first to think I need to triode connect this thing. Why wouldn't I have left it pinode connected? Why? Why did they decide? I would just about bet they had it pinode connected first and they realized they had to do this. And there's a couple possible reasons I can think of. And the first one is they had when the 6SK7's pinode connected, the voltage gain is going to be enormous. So you got this voltage gain going into it, and it's like that much more voltage gain. You know, it's like huge. And with it triode connected, you only get voltage gain's only 20. So that could have been the reason. Maybe they had way too much voltage swing. You know, and that's why they thought, well, let's triode connected to get that gain down. You know, that's one possibility. And what was the other one that popped into my head? There's actually more than a couple. But the main two, that would have been my first guess. Or they realized that they needed a little more current for some reason for the 6SR7. I wouldn't see why, but you know, there was one more thing I was thinking of, but I can't remember what it was right off the bat. But my guess is when the guy was designing this thing from day one, he probably started this thing out triode connected and realized there was a problem. Oh yeah, I remember the second thing I was thinking of, there is an issue with what the screen does on this tube when it starts going into AVC. Something happens. I think what happens is the screen voltage moves and it messes up what it's trying to do. So that could have been the other reason, which is what I was remembering originally too. Remember when I first said that triode connecting that would eliminate the problem with the AVC. So there is an issue with the 6SK7 when they're using AVC. I think the screen moves around too much when you start applying the negative voltage in the control grid. So that may have been the other reason why it was done. But I just need to see, because it's obvious the voltage would have to be, I'd have to have a couple hundred volts. You saw I went up from like 30, I went from like 40 something to 60 and there wasn't much change. So it's just there's too much gain. And see, I'm losing a little bit of voltage gain with this 6SRS7 using this like a hot cathode. Basically, it's in like a hot cathode phase inverter configuration like it is now, but it's really what it is. It's a phase splitter. I'm using it simply as a phase splitter. And you know why my voltage didn't drop down? Remember I told you the one thing I was worried about was the voltage on that. And I was thinking that may be a problem, right? And what was I saying here? Oh yeah, if it was going to drop down below 350, if I added that tube, and I didn't really want to add another tube because I thought more load, the more it's going to drop the voltage. Well, you know why it didn't do that? When I first started, remember I had 68K resistors in here. It was only drawn like 300, and I don't mean milliamps, microamps. It's drawn like, it was drawn 0.3 milliamps, which was like 300 microamps. And when I went down to 51Ks, it brought it up to just a little over 400 microamps, but that's microamps. This tube's hardly drawn any current at all, and this tube was only designed for 250 volts, and I think there's 3 1/4 just on the plate in this configuration, with what, 20 to 30 here on the screen? I mean on the cathode. And so that's, it's not supposed to have that much voltage on the cathode, but I think because it's only 400 microamps, even though it's a higher voltage, it's probably never going to hurt the tube. The current's too low, but therefore, since it's so low, it didn't, it therefore didn't lower my 350 volts. So I got lucky. This configuration is going to work like gangbusters, because from this point to the output of this 6N7 here, I only need voltage swing. The current here, I don't need much current. These 6 AS7s provide the current. You just have to have the voltage swing going into these tubes, enough voltage swing, and there's got to be enough current to keep it there. But you don't really need any current amplification. So that's why I thought, okay, let me tweak this, the output of this thing for minimum input signal, right? But I may have to go the other way a little bit to balance it out. We'll see. So let me play around with this thing some more, and God, this is a 21, almost 22-minute video. So we'll say 73s for now. Like I said, let me see what I can come up with, and see if I can really ramp this input up and get it to where it's not going to look any more than about like that, right? Because if it's doing this, that's kind of like, that's not good. So 73s for now.